Hello students, welcome to Year 9 Science and Unit 1, our chemistry unit on atoms and stuff. This is video number 3, where we're going to zone in a little bit more on some of those key theories that we've introduced in previous videos. This time around we're going to focus specifically on particle theory and the kinetic theory of matter to see if that helps us to gain a greater understanding of what's happening with our whole process of atoms and how they behave. The first thing that we need to do is have a little bit of a look at the difference between theories and laws. There's a lot of, I guess, misunderstanding about the difference between theories and laws. Sometimes people have like a hierarchical view that a theory, if it lasts long enough, will become a law. So laws carrying more weight in a sense than a theory. This is not correct. This is not a good way to think about theories and laws. The best way to think about the difference between a theory and a law is that a theory is an explanation for something that we see, whereas a law is a description. If you think about a lot of the laws that you may have been exposed to previously, they often have a mathematical relationship. So therefore, the different types of laws that you may have already seen, and one example of those may be, for example, Newton's laws. They help to give us a description of what we might expect to see happening in any situation. Probably the simplest one of those is Newton's second law, which is if you apply a force to an object, it'll continue to accelerate or increase its speed or change direction in the direction of the force that you apply. So a net force causing net acceleration. Now that's a description of what's happened. If you push something, it will accelerate in the direction that you pushed it. That's not telling you why it's doing that. It's only describing what will happen in this situation. And that's what laws do. Theories, on the other hand, are different. Theories are explanations to try and get to the underlying reasons of why something that you've observed has happened. One really good way to link the whole idea of particle theory and kinetic theory of matter to atoms is to look at something which we call Boyle's law. Now, Boyle's law, being a law, is a mathematical relationship. And if I was to give you a very brief description of this law, if I had a certain box, I've drawn it as a rectangle, so it's only two-dimensional, but imagine it like a box, like a rectangular prism. And in this box, there are particles, okay? There are particles. Little bits of matter. They may be atoms, they may be molecules, whatever it is, and they're all throughout the box, wherever. So these particles are sitting in this box, and this box has a certain volume, and volume is related to the space that the particles take up. And then they also exert a certain pressure. The particles are moving, they're in motion. Think of it as particles of a gas, because that's the easiest way to think about kinetic theory, particles in motion. We kind of understand that, you know, when we boil water, we see all of this steam escaping, and that's water vapor that's transferred from the liquid to the gas phase, and we see it moving. So it's easy to think about sort of particles moving, I guess, in the gas phase more than in any of the other states. So if we think about these particles and they're moving around, and what's going to happen is they're going to bump into each other, but they're also going to bump into the walls of the container, so the edges of the box, if you like. They're going to bump into that. Now, pressure is basically, you can think about pressure as how often these particles bump into the walls. So if they bump more often, then that's greater pressure. If they only bump every now and again, then that's less pressure. So the first thing we need to do is we need to think about what happens if we were to halve the volume of this particular box. What would happen if we were able to take this box and squeeze all of these particles up so that now the volume is halved? So if we halve the volume, we've made the volume smaller. We haven't put anything in or taken anything out. All we've done is, like a little syringe, we've just compressed everything closer together. What do you think is going to happen to the pressure? Well, Boyle's law is a mathematical relationship, and Boyle's law says if the volume goes down, then the pressure will go up. Mathematically, you'll actually see a direct mathematical relationship between these two things. That's all. Not why, just that's what you see. If you decrease the volume, you increase the pressure. If you increase the volume, make the box bigger, then you will decrease the pressure. Is there a way that we can use particle theory to help us to explain this phenomenon? Well, hopefully you can see that there is. If we start to look at the fact that Boyle's law is telling us about the relationship between volume and pressure, and if we make it a smaller space, then what we must have is more collisions. Smaller space leads to more collisions. So the particles are banging into the boxes more often than they were before. So this is going to increase the pressure, and this is an explanation for why Boyle's law works. So the properties of matter can best be explained using a model in which all materials are composed of tiny particles, either atoms or molecules or ions, as we've looked at before. Importantly, between these particles, there's empty space. But just as importantly, all these particles are moving. So the concepts of empty space but constant motion are really important when we're trying to explain the properties of matter, especially things like why Boyle's law works. The other thing that's important to remember is that particles in solids and liquids are much closer together than they are in gases. And so when we look at how particles are going to behave when they change state, that's going to be something that's very important in terms of the space between the particles. To summarize, these are the key aspects of particle theory. All matter is made up of particles. All particles of one substance are identical. Particles are in constant motion. Temperature affects the speed at which particles move. Particles have forces of attraction between them that hold them close to one another or push them apart. And there are spaces between the particles. To then think about kinetic theory, we really need to focus in on a couple of those aspects of particle theory, and it's very hard to separate the two, and you may have already started to realize that when we were looking at our explanation for Boyle's law. So let's see if we can focus in on these couple of extra things. Particles are in constant motion. Temperature affects the speed at which they move. Particles have forces of attraction, and there are spaces. So what are the implications of this for kinetic theory? The importance for kinetic theory is that energy can be transformed from one form to another. What we do when we add heat to any system is we increase the kinetic energy of the particles. This is because kinetic energy is equal to a half mv squared. That's a mathematical relationship that basically says any object that is moving has kinetic energy. The faster it's moving, the more kinetic energy it has, and the bigger it is, the more mass it has, the more kinetic energy it has. So basically there's a relationship between mass and velocity and kinetic energy. If you increase the heat in a substance, what you're going to do is move the particles faster. Particles move faster. That's what happens. So when we add heat to a substance, that heat energy is transformed into kinetic energy, and so those moving particles start to move more quickly. What do you think might be some of the consequences of this increase in speed? Hopefully now there's been a little bit of an introduction into the idea of particle theory and also kinetic theory. Which of either or both in combination of these theories are you going to be using when you're looking at Boyle's law? Particle theory or kinetic theory? And can you use both even if there is no change to the actual speed of the particles? Can you still use kinetic theory to explain something like Boyle's law? Well, that's something we'll have a look at in the classroom. Thanks for watching.